Hello and welcome to another one of D's ADD videos. Today we're going to be talking about the topic of center of mass. What is a center of mass? The formal definition is the mass weighted average position of the particles. What does that mean in English? It's basically the balance point of multiple objects or particles. So consider a system of particles or masses, and the system that they create will have a center of mass. And if you were wanting to balance this system, you would need to put your thing that you're resting on top of this center of mass. When you throw an object, it'll tend to rotate around its center of mass.
Mass is the position of the average of all the mass of an object or system. So if we looked at an object such as a hammer, this end has more mass than the handle, and so the center of mass tends to be closer to the head, so its balance point is here. Well, about there, right there. So if I was to throw this object, it won't rotate about its center, it will rotate about its center of mass. A rotating object will act as if all of its mass is concentrated at the center of mass. In this case, the center of mass follows a parabolic path. The same thing with this object right here. This is the center of the object, but the center of mass, there's a weight in here. The center of mass is offset. I can actually balance this right there on that point where I can almost balance it. Here we see the center of the object indicated by the black dot following a non-parabolic path. But when we look at the dot at the center of mass, we can see that it actually does follow a parabola.
The force of gravity acts directly at the center of mass. So if you wanted to just guess where a center of mass is, you could just try dangling the object and see where you would need to hold the object in order for it to not have any torque in either way or any turn. The most interesting part of this is whenever you have like planetary interactions such as the Earth and the Moon. You'll find that the Earth and the Moon expected but not the Earth, rotates about a center of mass. You would think that the Moon is just rotating about the Earth, but it's actuality both the Earth and the Moon are rotating about a center of mass located within the Earth's crust. So that's very interesting. It's not what you would really expect. We might take a look at it in an example video. But for now, these are the necessary formulas you will need in order to do most of these center of mass problems. You have the summation of the mass times the position of the mass over the summations of the masses. Now, if this is a three-dimensional object, by analogy, you should be able to form the Z center of mass, which would just be the summation of mi zi over summation of mi. Now, if you were to make that into a vector x, y, z, then this is what the formula becomes. All right? That's basically it for the center of mass. Practice, practice, practice. Check out the example videos. I hope I've given you enough courage to try a few of these. They're not too bad. At first it may seem overwhelming, but as long as you keep in mind certain basic principles, you're good to go. Thank you and have a nice day.